My mouth.
I don't know. Sorry. Let's try a couple problems from this list. They're the same kind of problems as the other one, except remember we're going to always use negative 9.8 meters per second squared as our acceleration. So we got a turtle. He's in the middle of the sky skydiving. He looks at his watch for 3 seconds, and he finds he's dropped 400 meters. What's his initial velocity when he started the whole experiment? We're going to neglect air friction. Well, he fell 400 meters. But he fell down. So remember, we're defining down as negative y. So we're going to call that negative 400 meters. This is the one we want to know. The acceleration is going to be negative 9.8 meters per second squared the whole time. And we know he went for 3 seconds. So this is the one we're not interested in knowing. So our equation is going to be the one that doesn't have the final velocity. T equals VOT plus 1/2 AT squared. So we'll have negative 400 equals the initial velocity times 3 plus 1/2 negative 9.8 meters per second squared, 3 seconds quantity squared. Well, this will be negative 400 equals VO times 3 seconds. Sorry, I left that out. Plus 1/2 times 9.8, that's 4.9, times 3 squared, that's 9. I think it would be 4.9 times 9 would be negative 44.1, I think. And that's meters. Okay. I bring that to the other side. I'm going to add 44.1. So that's going to give me negative 355.9 equals VO times 3 seconds. And this is in meters. Divide both sides by 3 seconds. I get the initial velocity is going to be 17.9 or something like that. And it's negative meters per second. Notice that's negative. That's good. That means that he started falling at, a negative speed. Whoa, was that fast though? That is really fast. What can you do? So that's good. Okay. The next one, elephant's falling at 4 meters. In the short time later, it's falling at 9 meters. How far did it fall during the short time? Again, you're neglecting air friction. So we're going to say the acceleration right away is negative 9.8 meters per second squared. Okay. Now, it says he's falling at this speed. That's kind of tricky. That means his initial velocity is going to be negative 4 meters per second. And the final velocity is going to be negative 9 meters per second. I'm going to find out how far he fell, because we don't care about that. Go to our equation list up top. The one that doesn't have time in it is that one. So we'll go ahead and use V squared equals VO squared plus 2AD, which means we have negative 9 meters per second squared equals negative 4 meters per second squared plus 2 negative 9.8 meters per second squared. Oh, sorry, this is meters per second quantity squared, my fault, times D. So it'll be 81 meters per second, or meters squared per second squared equals negative 4 squared. It'll be 16 meters squared per second squared minus 19.6 meters per second squared times D. Well, 81 minus 16 will just give me 65. Is that right? Yeah, that's right. So it'll be 65 meters per second squared equals negative 19.6 meters per second squared, all times d. I divide 65 by negative 19.6, and I get, I think it's 3.3, negative 3.3 meters. Remember, it's negative because it's falling down. By the way, on this sheet, skip because 3 because it's not falling. Skip 6 because it's not falling. Skip 8 because it's not falling. And just do the ones that are on the other sheet too. That's plenty. And thanks, guys. I will see you tomorrow.